Okay guys, we will move on to this next part of your ionization enthalpy, the last part. Here guys, we told that along the period ionization enthalpy will increases, right? Along the period ionization enthalpy will increases. Okay, here guys, for your second period, that is for an lithium period, in your NCERT group they mentioned the ionization enthalpy graph. Okay, the graph for your lithium period, this complete period, they mention the ionization enthalpy graph. Okay, and you may observe that one more graph is there, that includes, they represent ionization enthalpy of first 60 elements of your periodic table. Okay, one more graph is there, they will represent ionization enthalpy of 60 elements. There you can found that there noble gases will always have an highest ionization enthalpy. You can look over into your NCERT books. There, the graph is there for your ionization enthalpy for 60 elements. There, the noble gases will have always ionization enthalpy in an highest value. Okay, because this will have an filled and stable configuration. That means what? Your noble gases will have an NS2 and NP6 configuration. That means here all the orbitals of your element of noble gases were filled, and this configuration is highly stable. And we need a more amount of ionization energy. To remove an electron from this outermost p6 orbital. Then it will be converted to NS2 NP5. Okay. Here guys, for the conversion of NS2 NP6 to an NS2 NP5, that means this configuration is highly stable configurations, and this is for your noble gas. For the conversion from P6 to an P5, we need a more amount of energy because this configuration is highly stable configuration. And one more thing, this configurations will consist of filled orbitals. Okay. And one more thing guys, here for your second period, we knew that along the period ionization enthalpy increases, right? And whereas the second period consists of lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Right? These were what? The elements of your second period. In this series here, the beryllium and boron. Okay, along the period, we are moving along the period from beryllium to boron. Obviously, the ionization enthalpy along the period increases, means when we move from beryllium to boron, ionization enthalpy should be more. But actually, the ionization enthalpy for boron is less than beryllium. Actually, the ionization enthalpy of boron is less than beryllium. The reason is what here, and beryllium consists of a configuration of 1s2 2s2. That means it is having a 4 electron beryllium. It will have a configuration of 1s2 and 2s2. Whereas boron, it consists of 5 electrons and its configuration is 1s2, 2s2 and 2p1. Okay, 2p1. And one more thing guys, here you guys has to know this concept. If the orbitals of inner core means what? This one. Inner core means what? Here 1s2 and 2s2. If these were filled, that means S will have a capacity to hold only the 2 electrons. That means these s orbitals were filled. Okay. If these were filled, means this will cause us more screening effect. Okay. Filled orbitals will always cause more screening effect. Keep it in mind, screening effect will be more for filled orbitals. Okay. Here it is unfilled orbitals, and next comes 2p1 and boron will have an lesser ionization enthalpy compared to beryllium. Means the reason is here this is what unfilled orbitals present proceeding to your 2p1 electron, so that the screening effect caused by this orbital will be more in effect. Then your 2p1 electron is there, and we are moving from 2s2 and 2p means again the distance is somewhat increased from the nucleus. We are moving from 2s to 2p means again the distance is increasing. Distance increases means attractive force will decreases, right? And here the reason is why your boron will have a lesser ionization enthalpy means it will have unfilled inner core electrons. This will screen more for your 2p orbital. If the screening is more means attractive force will be the less. If attractive force is less means then ionization enthalpy decreases. Why boron will have a lesser ionization enthalpy compared to beryllium? The reason is what? This consists of an inner core filled configuration, and this will causes more screening effect. So the attractive forces between your nucleus and outermost 2p1 electrons will decreases, so that ionization enthalpy will decrease. Okay. Here you look over here 2s2 orbital and 1s2. Here 2s2 is filled orbital. Again here 2s2 is filled orbitals, and I told you here guys, if filled orbital is there, then that will be unstable one, and we need and more ionization enthalpy. Ionization enthalpy is more. If the orbital is filled, we need and more ionization enthalpy to take an electron from this one. Okay, if you take an electron from this one means the configuration becomes what? 1s2 and 2s1. Okay, so to take an electron from this is what unfilled configurations, we need a more amount of energy, so that beryllium will have a more ionization enthalpy compared to boron, because more shielding effect caused by this filled orbitals for the 2p orbital, and so because of more shielding, attractive force will be less, ionization enthalpy is also less. Okay, and next one more thing is that when we move from nitrogen to oxygen, again ionization enthalpy decreases. But according to our variation, ionization enthalpy along the period has to increase. But in the variation from beryllium to boron, it will decreases. You guys know the reason. Whereas when we move from nitrogen to oxygen, again the ionization enthalpy decreases. Again, the reason is here nitrogen its atomic number is what? 7, and its electronic configuration 1s2, 2s2 and 2p3. 1s2, 2s2, 2p3. That means 2p orbital consists of 3 degenerate orbitals, and each orbital will consist of 3 electrons. 1 electrons. Okay. Here, whereas the oxygen will have an atomic number 8, and its configuration is 1s2, 2s2 and 2p4. Okay. Here 2p4 is there, means in your 2p orbital we are having 3 degenerate orbitals and 1 electron, 2 electron, 3 electron, and 4 electrons will comes to have again the first degenerate orbital. Okay. Here why oxygen is having lesser ionization enthalpy compared to nitrogen? The reason is the same thing here. Here we knew that electrons and electrons will always repel each other because of the negative charge. Okay. 2p4 means the two of the electrons will occupy in the same degenerate orbital. two of the electrons is occupied in the same degenerate orbital, so the repulsion will increases. So the repulsion will increases means electron repulsion is increased means that we can easily pick up this electrons outside from the oxygen atom. So the amount of energy needed to take this electron is less. Okay, whereas in nitrogen we will have all the degenerate orbitals with singly occupied, whereas in oxygen we having one degenerate orbital with a double occupation. Because of this double occupied degenerate orbital, the repulsion between the electrons will increase. Repulsion increases means we can easily take one electron from the oxygen atom. If you take one electron from an oxygen atom means it becomes 1s2, configuration becomes 1s2, 2s2 and 2p3. If it is in 2p3 state means again each degenerate orbitals will have one electron each, and there is no repulsion between the electrons, so that ionization enthalpy need to remove an electron from this state will be obviously more. This is what the reason why oxygen will have less ionization enthalpy compared to nitrogen, and why boron will have less ionization enthalpy compared to beryllium. This ends your ionization enthalpy concept. Okay, this is what a complete picture of your ionization enthalpy, and you guys observe each and every concept carefully because this will help in your entrance. Okay, thank you.